Welcome to a presentation on our new AccuSizer software. As you look on the left here, this is the AccuSizer 780 series, and this is the software that we have been using to run that particular line of instruments for quite a while. And on the right, this is the new A7000, A2000 instruments, and down below the software that we're going to be talking about today. So kind of talk about going from the old design to the new design, and from the functional software to the, dare we say, fabulous software. So that's a topic we're going to talk today, mostly about the software, but also some innovations and changes in the hardware that the new software allows us to perform. There are a lot of improvements that have been built into the new software, including running the instrument, a lot of automation, being able to run the Autosampler, how we report the data and data management in general, user management in terms of security and just giving users different levels of what operations they can or cannot perform. For people in the pharmaceutical industry, we have enhanced 21 CFR Part 11 features. The calibration procedures are easier, more automated now. Again, for the pharmaceutical people, to validate a system for making USP 788 measurements has been improved. And the documentation, the manual release notes is vastly improved as well. These are the things we'll be pointing out today. The software will run all of the AccuSizer A7000 and A2000 products. So it's one software package for all of the platforms. When you first turn on the software and configure it to work with an instrument, you have this pull-down menu where it asks, okay, which hardware am I hooked up to? And you can choose which of these we're going to be operating with the software. I should point out that as of today's date, this is not yet available to run the online mini systems, which are used in the semiconductor industry, or for the focused beam sensors, the FX Nano systems. This is for the AccuSizer A2000, AD, APS, SIS, and the direct inject system, and anything that works with the new Autosampler. We have two versions, 21 CFR Part 11 compliant and non-compliant. And if you're saying, what in the heck is that? That means you're probably not from the pharmaceutical industry. So in the pharmaceutical industry, they actually have the FDA looking over their shoulders, and they have to worry about federal regulations. CFR stands for Code of Federal Regulations. And there was a chapter that came out years ago, this Part 11, which talks about electronic signatures and electronic records. So we do have these features available for people working in the pharmaceutical industry. People in other industries really would not need any of these features whatsoever. It's written currently to operate in the Windows platform, ranging from Windows 7 up through Windows 10. Every time we release new versions of this software, we actually, when we release it, send out the release notes. This is just a summary of a release note that you see here, which explains everything that has changed within the software. Have bugs been fixed or have new features been added? So this is new for us and very helpful for people saying, okay, you updated the software, what has changed? There's also a very extensive manual, and I show a page here from the list of what all is in there. You see it goes up to page 217 before it gets to the appendices. And I could just bounce over to the manual here, and I'll just go up to the table of contents. And in the table of contents, you're just going to get a feel for how extensive and thorough this manual is. And as I said, you can see the current number of pages goes up to, I think you'll see down here, 217, and then goes into several appendices. So thank you, Donna, for all the work you put into making this a very helpful and complete user manual. The way the software works is we call this a docking software in terms of different windows you might use to perform different functions. You can place them where you want on the screen or kind of make them disappear. So for instance, I show here the window for doing maintenance with the syringe sampler. So you could keep this open all the time and you could just click on a button and initialize the syringe or flush the syringe. You can adjust the flow rate to see what's going on with the sensors, and you can have this available at all times so you can reach in and perform these functions. Or if you're just doing automated functions, you can just make it disappear or dock it where you would like it to go to. The first thing you would do when setting up the system is go to the Instrument Settings windows. And you see on the left Instrument Settings for the syringe sampler, and for the right, so I'm not sure which one this is, one of the ones that has different diluent pumps, maybe an A2000. So in the Instrument Settings windows, you can configure your system for the details for how your particular instrument has been set up in terms of the syringe size or which pumps are you using, which voltage levels you want to set as limits for your sensors, and then general settings for how you're performing the sample down here. So this is one of the first things you do is set up your system, and this is really very helpful, being able to set up these voltages for your sensor. So we can constantly look at your voltage settings, and if we ever exceed or go underneath these settings, you'll have a warning, or you could actually stop the measurement. So this is another way to make sure that the data collected is only collected when the instrument is within proper operating parameters. The next window we will go to are the protocol windows, and the protocols are how we explain to the software how we want to perform the measurement. This particular window we're looking at here is for the SIS sampler, the syringe sampler. This is where we tell it what's the measurement volume, what flow rate, what size do we want to begin measuring at, how many replicates, etc. So all of this is a very nice organized way to say how are we going to perform the measurement, but in addition we do have new features built into the software. So for instance, being able to work at low volume measurements, we've improved the accuracy of the syringe so we can measure sample volumes as small as 100 microliters. You see this button for preserve sample. We can bring the sample up into the syringe and into a tube coil and then return it to the original container so that we return the sample. In its non-destructive testing, you could use the same sample then for other analyses. Another new feature is push-pull, and this push-pull mixing is how we can actually take the sample up and put it back down, back and forth into and out of the tube. And that is how we can do mixing without having to actually swirl the bottle. So new features are also built into here to improve the capabilities of the system for making these measurements. Here I'm showing the protocol windows on the left for the AccuSizer APS and on the right for the AccuSizer AD. The AccuSizer APS is our dual-stage dilution system. Then here we can put information such as what kind of volume are we putting into the system, what size do we begin our measurement, and also what's our DF2, which is how we decide what kind of dilution ratio do we want to be working at. Down here we choose the measurement mode, and on the right we see the setup for the AccuSizer AD, which is our single-stage exponential dilution system. And then here we want to put in information such as the configuration. Are we going to do a gravity drain or a pumped meter drain? At what concentration do we want to begin our measurements? And the other information in terms of how we're going to perform the measurement. So very easy windows to configure the measurements how we want to perform them. On the left on this slide, to the left, this is the AccuSizer A2000, which is a contamination monitor where we have multiple stirrers and sometimes multiple pumps, and this is how we would configure that system to perform these contamination measurements. And on the right, this is for the direct inject system, which is always used in conjunction with the Autosampler. But in here we can say how much sample do we want to measure each time, equilibration time, what kind of concentration do we want to start measuring at, what's our background counts. So this is how we would set up the direct inject system when we're going to work with the Autosampler. So that was the instrument setup. The next tab in the protocol window are channels/physical properties. This is where we tell it how many of our size channels do we want to use, with a maximum of 1024, or if that's too many, 512, or maybe even less if we don't want to show all that many size channels. We set up the baseline offset, which is basically if there's only a few counts in a channel, let's not include that in our calculations. This PFAT5 section is very specific to a single application, which is measuring lipid emulsions in the pharmaceutical industry. And the USP 788 settings here is also for the pharmaceutical industry, where we need to tell the system how many containers did we pull and what was the volume per container. So these channels' physical properties are the next step in organizing our measurements and is in the same tab within the setup protocol window. The last tab in the protocol window is reports, and this is really one of the ways where the new software vastly expands our capabilities. So in here we can say, do we want to run the reports automatically, which can save time and effort. That's what I typically do when I'm making measurements. If we want to do full reports or custom reports, we can make those decisions here. What kind of distribution values do we want to show? Which graph would we want to show in the final printed report? What statistics to show, etc. And then we can also talk about how are we going to export the data. So many more options and features in this report tab. As we continue looking at these reports, there's a lot more. This is just showing some of the reports already built into the software. You also have the ability to create your own custom reports. And down here, another new feature is multiple sampling reports, where we could say we're going to take 4 samples, but we're only going to select these 3, and then generate the report just based on the selected results. And that could come in handy for some measurements such as USP 788, where we might want to take 4 pulls of the syringe, but then just do an average of the final 3. So this multi-report is a new feature in the software, which is very helpful in several applications. As we look at some more detail in the reports capabilities, we can have custom reports, multiple region reports. I'll show you how regions are set up in just a moment. So we could say we're going to collect the data, but then we're going to break up regions. And I only want to look at data from 10 to 25 and 25 to 100 microns. And we could create reports on regions within that total overall sample range. Then on the right, we're showing some of the options of how we're going to export these reports. These are some options in terms of PDF, Adobe Acrobat format, into Excel or into CSV reports, and we can also take these reports and automatically export them into the LIMS system you may currently have organized in your laboratory. So let's say we have organized our measurement and we now have it set up as we want it to both measure, analyze, and report the data. What we're going to do is when we click Start, we'll have sometimes these dialog boxes explain to the operator what they should be doing at any given moment. For instance, perhaps there's a step before analyzing the sample where we're going to run clean diluent. Then there will be this kind of a box saying put the clean diluent sample bottle into the system and we're going to start measuring that. Once we start passing the clean diluent through the system, then it's going to say, okay, now put in the sample beaker and we're going to measure the sample. You click OK then, and then during the measurement we have this real-time plot. And on the real-time plot we get information on the concentration of particles and particles per ml, and also a constant reading of sensor voltage. And as I pointed out before, this is very helpful to tell us the health of the sensor. Is it operating properly during the measurement? And if at any time we either go above or below these sensor voltages, we may want to stop the measurement and see what's going on there. Perhaps we need to clean our sensor. So we analyze the sample, and now we're going to go and report the data or view the data and then create these reports. The information from the results is organized as you see on the left here. So we always have a new project, and within a project then we have, for instance here, these are the samples we analyzed, and then for any given sample we have different ways to view the data. And at this point I'm going to pop over to the actual software. And here in the software we see data that I collected a little while ago. This is an active pharmaceutical ingredient, an API I was working on a little while ago. And what you see is this is my data from run number 3. And this is a graph of the data. Within the graph you see the units I'm currently looking at are particle counts versus particle size on the x-axis. I can quickly change this from particle counts if I go to units and go from counts versus size to something like volume versus size. So now I'm looking at the volume distribution, percent volume versus size, as opposed to just counts. And as you look at the units here, there are quite a few options, including options we've never had before, such as counts versus volts. So there's a lot more options here in terms of how we're going to view the data. So this is a graphical representation of the data that I collected. We can come to results summary. In results summary, we see a lot of information, which includes the statistics such as the mean, median, mode, and we can get these statistics in both the number, area, and volume basis of the distribution. This gives us some overall information on the sample, which is the same for all the different representations, and here we break it into how do we like to view our final distribution. It was run by someone named admin, but if we had actually taken the time to set up the users, we'd know who had run the sample. We have all the setting informations here in terms of how was the system configured and operating during the measurement. We see all the details of the protocol that was used for the measurement. And I didn't include any extra data calculations, but here's where we could see what information was used for additional calculations. And we even have here information about the calibration curve used for the sensor. So this is just some of the information available for any result that we analyze. And this is major improvements in terms of accessibility to the data, understanding how the sample was run, and also displaying it using many different formats. So many improvements here. Another improvement is the ability to set up regions. And for instance, for this particular sample, let's see if I've set up any regions for these. So here I set up a region. Within this region, it goes from 10 to 25 microns. I can just step into here and for the regions get the statistics for any region. So many additional ways to view the data and to zoom into the data and get the information just for regions within a given result. So that was just showing some of the capabilities of ways that we can access the data after we have completed the measurement. We also can report the data in very specific ways for very specific applications. For instance, in the pharmaceutical industry, there's this USP 788 test for parenteral drugs. And we can automatically calculate the average of multiple runs and then get a pass-fail criteria based on the number of particles per ml in each container. We see here a sample where we passed the criteria and one on the right where we fail. So automatic pass-fail calculations is very helpful for people performing these kinds of measurements. When you're setting up the system for USP 788, there are additional tests you do before in terms of making sure the instrument is properly configured and meeting the required operating specifications. The more complicated of those tests is something called the sensor resolution report. And I just show you here the result of doing the sensor resolution test and the automatic calculation of sensor resolution, in that this passes that requirement. So this is a much easier way to configure the system and make sure it's operational and meeting the requirements of USP 788. That's just one of many tests where we have these custom application reports. I show here just some of the other applications. These are pharmaceutical. This is really contamination applications. We're looking at cleanliness in oils and in other fluids. We already have these reports written for these applications, as well as the ability, as I'd mentioned before, to create custom reports. This is showing a report for ISO 4406, which is an ISO standard to test oil, hydraulic fluid, and other kind of fluid contamination levels. We look at the number of particles per ml, and for any given concentration, you come up with these scale numbers. And then we have on the right this automatic report from the new software, where we're showing the particle concentration at these different size ranges. And here are the classification numbers, which come from the table on the left. So automatic reporting of the requirements in various industries makes it much easier for operators to report the results from the system. So we've made the measurement, we've collected the data, we've generated the reports. Now also there's a lot more we can do in terms of organizing this data, because now all the data is stored into a database and we have various database tools to help us organize this data. All the data is encrypted, and we can export this data in various units, such as counts per size, counts per volts, runtime data, so we can export the data using our various reports in these various units. In addition, we have the ability within the database to export the data in the formats I had mentioned, such as CSV, Excel, and other extensible markup language, other formats, and this can also allow us to export the data directly into a LIMS system. Another very useful database tool is we can have it automatically back up our data. So not all of us are completely perfect to making sure we back up our computers all the time, but we can automatically have this set up so it will back up the data, and we can restore it if we need to, if there are any issues down the road with how our data has been stored. Another function I really like is the ability to search the data. So we have a database tool which allows us to reach in and say, okay, I'm looking for data from this project, having this kind of name, measured on these kinds of days, measured on that instrument. And then this will automatically search through the data and only turn up the results that match this search criteria. So I find this very useful because I'm not always the most organized person, and then 6 months later I say, wow, I had this great data, can I go find it? That's now very simple using the database search functions. If I'm the person who's managing the laboratory, I might actually want certain people in the lab to be able to create protocols and some people just to run protocols. And that's just one example of ways where we can give users different levels of ability to use different features within the software. So here we can enter a username, set a password, and then here you see what are these people authorized to do. Can they change protocols? Are they allowed to change security systems? And it's a long list, so we can set up the different users to have different authorizations. And this may be very helpful if we're working in an environment where we really need to lock down the measurements and make sure they are measured the exact same way every time. We've also extended the security features just to kind of bring them up to date. In terms of how long does the password need to be? Does it require special characters? Will we lock people out after a certain number of attempts? So improved security settings. And on the right, we see electronic signature settings. So at the end of a measurement, we can actually have it so that only certain people can approve a result. So a measurement has been made, and maybe we want the lab supervisor to review the data and say, yes, this is run properly, and yes, we think this is data that should be saved and approved. So I may need to log in and say, okay, I'm the reviewer, sign in with a username and password, and then sign it, and then you end up with this electronic signature saying it was approved by this person on this date. So this is improving the capabilities of controlling the data after we have run it to make sure it has been approved by somebody at a certain managerial level. We also can have a log of all changes made to the software, and that can just be an audit log or an audit trail depending on if we're in the pharmaceutical industry or just a laboratory who wants to track what's happening with the system. So we see here just an automatic log that anytime anything changes with the system, there's a log to say on this date a security setting was changed or something like that. So a good way to track the control of the instrument so we know if any changes have been made to how it was used. The calibration features have improved quite a bit. What you see above are the calibration curves. One is the extinction and one is the summation. But down below, this is actually the calibration manager, and this is a tool which makes it a lot easier to go in and check the calibration or perform the calibration on a sensor. And I did this recently at a customer site, and I really like these new features. It made my day operating as a service engineer doing the calibration go a whole lot easier. This window we really keep secure for either people who work directly with PSS or local representatives, because we don't want people to get in here and make all kinds of changes and end up in a bad place. But for people who are trained in performing these calculations, it is much easier with the new calibration manager tools. All of the AccuSizer systems I've shown you today can be interfaced with our new Autosampler, which you see here. And the new Autosampler can work with trays up to 90 samples per tray. Here you see the AccuSizer where we actually have the sensor mounted right on the arm. We have different configurations for the AccuSizer depending on which fluidics we're going to interface with. The picture you see down below is actually what we call our direct inject system. So here we see the mechanical stir that's going to come down and stir this sample before making a measurement. As I'd mentioned before the webinar started, this is designed, for instance, for measuring alumina in certain applications where you only want to mix a sample directly prior to the measurement. That way each sample only experiences the exact amount of agitation. It then takes the sample and directly injects it into what is essentially the beginning of our AD, exponential auto dilutions fluidics, over here to the right. And we have dedicated systems such as the A2000 CMS for high throughput oil contamination measurements. Setting up the Autosampler is much easier now in the new software. What we see above is basic Autosampler settings such as how far down into the tube to go, how much sample to transfer. What you see down here is for each given tube in the Autosampler, we can choose what is the protocol, the sample name, and you don't have to run the same sample protocol for all of the tubes. You could have a different protocol for each, but that would be a bit extreme. We set up how big is the tray, do we want to measure each sample. And on the right, you just see the window of setting up the maintenance for the Autosampler.
Another wonderful feature about this new Autosampler tray setup is you can go into Excel now, and you can define what measurement you want made per location in the sample tray. So for example, if you look at the bottom of the screen that Mark was just located at, where it says import, that's where you would import your spreadsheet from Excel. And I think you do have that next screen up there.
Mm-hmm.
So for example, you can go ahead and define your own parameters per location in the Autosampler tray. It's a wonderful feature. We're finding a lot of users using that at this time.
Absolutely, especially people who have very high sample throughput who need to set up for making hundreds of measurements. At that point, having access to just typing the data into Excel and then loading it into our software here makes it much easier to do the setup. Thank you. So major improvements both with what can the Autosampler do, but also the ease of use of programming it to do what you'd like it to do. And at the end of the measurement, we can export data so that it can interact with the LIMS system, because if you're going to measure 200 samples a day, you don't want to have all that paper hanging around. Typically, you want to choose which data points are important and export that directly into a LIMS system to automate data collection. So that's the information I wanted to show today, to just give you a feel for the major updates and innovations in the new software. We've improved all phases of how to prepare the system, how to make the measurement, how to report, and how to deal with automation. Database tools for managing the data. Custom reporting so that you can have the data in the format that's most important to you. So hopefully anyone who's used our old software would see the major improvements with this. And of course, yes, we can help you upgrade your existing system. So if you see something that was presented here today and you say that would really make my life easier in my lab, please contact your local sales representative and we will find the way to help you upgrade your system so you have access to these new features. If you do want additional information on any of our systems and also on the software, on our website, under the Documents section, you can actually download the latest application notes, technical notes, including things like webinars, which I will probably take today and post also on our YouTube channel. So that's what I wanted to show you today. I want to thank you for your time, and hopefully this has given you a good feel for what all we can do with our new AccuSizer software.